Welcome back from the previous episode where we spoke about the architecture workflow, especially how the class loader works in cooperation with the runtime environment. In this time, we are going to speak about Java class loader, first component we use in Java virtual machine. How the class loader works, starting by class loader. You are a developer, you wrote already your Java class, then you compile it, so you produce your main.class, a bytecode file. You will send it into the class loader. The class loader is going to do three main operations. First one, it will be loading. Loading means that the class loader, one of three of them, will load your class if it exists. We have first one application, second one extension, third one is bootstrap. They are the main three class loader we have them in Java. For sure, you can write also your own custom class loader if you would like to do so. So first of all, when the main.class get into the loading phase, application will send a request to the extension sends a request to the bootstrap. As a delegation pattern, bootstrap is going to make a quick check in its loader classes. If already this main class exists in bootstrap, it will load it. If it's not exist, it will send the request to extension. If it's not exist, it will send the request to application. So that's how it works. Delegation, child asking parent asking parent until it's found it, then load the class if it exists. After the loading phase is done, we have the linking phase. In the linking phase, also have three different phases, starting by verifying. Verifying is making sure that this main.class is already having no error, everything is okay, the bytecode is fixed, the major version are okay, there is no issue in the code itself. When verifying is done, you will send to the preparation. Preparation means that any default value, any variables you have in your class will be assigned to its default value. It means that if you have, for example, integer as a variable, this integer will take the value of 0. If you have a reference class, will take the value of null. If you have a string, will be null or empty string as a default value. After the preparation phase is done, we go to resolve. Resolve means that already you have an empty class with the default values. Now it's time to resolve all this default value to its actual value, which you as a developer assign it to it. For example, you have integer id. This id in original value has 10, but in the preparation phase it was assigned to 0 as a default value. In a resolve phase it will be assigned to the actual value, which is 10. Everything is okay with linking. That will take us into initialization phase. Initialization phase means that okay, your class is ready and now it is initialized. That was overview of the class loader, how it works from loading the class, linking the class, and initializing it. Now let's get a bit into the class loader in details, starting by what is class loader. Once more, class loader is object that is responsible for loading classes when it refers to it first time, because usually when you start loading your application, every class object contains a reference to the class loader that defined. So that's on a startup. So class objects for array classes, for example, are not created by any class loaders but are created automatically as required by the Java runtime. That's for arrays especially. We have three different types of class loader. Let's check them one by one. We have bootstrap. Bootstrap is the parent and the main, which contains all classes file of Java Standard Edition in your runtime environment. After the bootstrap, we have the extension. Extension responsible for loading all the jar files located inside Java Home GRE lib extension directory. If you have something there. Application or system class loader, it loads the class files from class path. Default is the same directory. Class loader type, there are few principles which class loader using it to work. First one is visibility. Child class loader can see the class loaded by parent class loader, but not vice versa. Why not vice versa? Because class loader parents cannot find the class loaded by a child class loader to guarantee some isolation level to avoid also duplicating loading of the same class. Uniqueness. Uniqueness is similar to visibility because a class loaded by parent shouldn't be loaded by class child loader again to avoid duplication loading of the same class. Delegation is a design pattern, which means that the child class loader will ask the parent to load the class before attempting to load it. So always delegation working that way. Child asking parent make a check. If it exists, it will load it. If it's not, it will send the request for the child to search in its class loader, so it will load this class. Workflow. Here is your main.class. After you compile it already, you load it using the loading phase. Loading starting from the main class. Any Java application, regardless where this Java is used, it should have only one entry point. Usually we have a static main method. It is the only entry point for your Java application. The loading starts from main and it's loading the subsequent class which called after that from other method or other classes inside main, one after another. After the loading, we have the linking. Linking involves the verifying, preparing the loaded class or interface. Its direct super class and super interface if they are exist, and the resolution of symbolic references in this class, etc. Linking properties. First of all, a class or interface is completely loaded before it is linked. You can't link a class if it's not already loaded. A class or interface is completely verified and prepared before it is initialized. To guarantee the health of your class, you can't initialize it if it is already incorrect. Errors detected during linkage are thrown at a point in the program where some action is taken by the program that may directly or indirectly require linkage to the class or interface involved in that error. So the early detection of errors is one of the security advantages in Java. By this way, you avoid any work after you load your class if it is already has some error. Linking involves the allocation of new data structure, so it may fail with an out-of-memory error. Sometimes that could happen if you have, for example, a for loop which call or produce or create any number of objects and you store this object into your memory. You should be aware when you work especially with loop, if you create a class, you should somehow after that like destroy it or assign it to null or dereference it later on. But anyway, Java garbage collector will do that for you as well. But be careful with working with loops, especially if it's involving with some kind of object creation. Takes us to the 3 stages of linking, which verification. Verification to ensure the binary representation of a class or interface is structurally correct. Do you remember from the episode we made about the class content? This class content, it should be during the verification verified that everything is okay and it has the necessary variables argument with no error inside this class. May cause additional classes and interfaces to be loaded but need not cause them to be verified or prepared. The reason for that because sometimes you have within your class you have a reference to another class, so you need to call this class as well before continue verifying or loading the same class which you are using it. Takes the longest time, and that's for sure to avoid issues during the execution. Preparing, verifying takes some time, but that's also a good guarantee for you that your application will work smoothly with no unexpected error or issues during the runtime. If verification fails, it will throw runtime error such as java.lang.verify error. You will get this error early so you can fix it early. Second stage is preparation. Preparation when you create the static fields for a class or interface and initializing such field to their default value. We spoke about the default value. It depends on the data type of the variable. It will take the default value of that data type. Object will be null, string will be empty, integer will be 0. May occur at any time following creation, but must be completed prior to initialization. It doesn't make difference. Sometimes preparation, verifications are working hand in hand together to make sure the class is good before initialize it. Resolution, which means that if you have already your class assigned to the default value is ready to be used, now it's time to use the actual value which you stored it somewhere in your runtime data. We will speak about this next episode, but now you just need to know that in resolution you will assign your variable the actual data which you are as a developer assigned it to it during the development phase. Resolution, if it fails, you will have incompatible class change error. That takes us to initialization phase. Initialization phase is so simple. All the static variables are assigned with their original values defined in the code. and the static block will be executed if there is any static block in your class as well. Executed line by line from top to bottom in a class and from parent to child in a class hierarchy. Initialization phase, it will not take much time because already you took a lot of time during the preparation, the verification, and the resolution. Sometimes when you work with application, you can get some exceptions, especially the class loading workflow. Exceptions such as class not found exception when you try to load a file for a class which not exists. Somehow in the middle this class got deleted by you, by an error, or by something wrong during the workflow. No class defined error. That could happen during the resolution stage when you have, for example, class X and inside this class there is a reference to another class Y, or when you try to load the class from within a method call and this class is not loaded yet, you got that no class def found error. Class cast exception when you are improperly cast a class from one type to another. For example, you have a string and you want to turn this string to be integer, but the representation in this string, it is only string, there is no numbers there. Unsatisfied linked error. Java virtual machine cannot find appropriate native language definition of a method declared as native. If you use some native code inside your application but you don't have the appropriate language or the library itself, that's it for the class loader. Next time we are going to reveal what is under the hood of the method area, the BC register and native method stack. Stay tuned. Thank you so much for your time and watching. See you next time. Peace be upon you.